Okay, so if I remember correctly, at the end of class on Wednesday, we were getting a weird behavior with the move to, right?
Yeah.
Not on that screen. On this screen. All right, did somebody happen to experiment with it and figure out what was going on? No? Okay. We have them all set to run. Well, we don't have that guy set to run to completion. Then we undid it. All right, well, let's turn them all off for now. Okay, so our intended thing is to go from where it's at now on X to a new Y position. So we want it to go up, then we want it to go over, then we want it to go down. That's ideally what we want to happen, correct? And this last one was just kind of a test thing to see if it would, like maybe if it was an even or odd number or something or other, something like that. Doesn't that seem stupid? That if I'm on this scene that...
Can we switch up the order of them?
Well, we certainly could.
I mean, what if you...
Put that one in the middle or something.
Let's try it.
So this says go up, then go... Yeah, this one would say go down to the right. And then do...
And straight over.
Well, actually, this one should say don't move. Because right now, because we're going to go to 280. So we'd already be at 280 and then wherever the current Y is. So this third one would say don't move. As it is right now. Because it's going to move to the same position as we've gotten to on this guy. Okay, so that sort of indicates that this guy's happening first. Let's just take him out. So this says go up. This says go over and down. Correct? So if this works, it should go up and then down at an angle. Okay. Seemed legit enough. So let's throw another move to in here that says go to 400. No. Go to 280 on X and whatever Y currently is. Right?
Mm-hmm.
Which I know is the same logic we had before, but I don't know, maybe there's something buggy with the... Wouldn't be the first time. Okay, so go
Up, over, down.
Up, then move to 280. Then, let's not say 280 here. Let's say RX. Down to 89. Okay. I'll be able to click one of these days. We have it speeding at 300 right now, but clearly it did that first, right?
Mm-hmm.
Why? Why, oh why?
Is it combining them because you're just using the self? So it just looks for whichever hard code you put?
Possibly. we could start off at, let's try replacing all the selves with exact locations. That'll
I think it's
give us some information. So this guy's currently at 127.89. So we'll say go from,
it's 89. X is 89, Y is 127.
what was it? Okay, so go from 89 to 190, right? That'll go up. Then go from a,
No, wait, was I? Did I have it backwards?
yeah, I think you did have it backwards. All right, hold on, we
It's
gotta,
127. That much I remember.
X is 127, Y is 189, or just 89.
My bad.
Okay, so we're gonna go from 127 on X
Wait, can you move that's
190.
the X.
Huh?
Yeah, that's the X, not where it's moving from, isn't it?
Yeah.
So
Right, we're gonna leave it. We're gonna stay in the current X position
Okay,
and just go up.
okay.
Right? So we're gonna go
Right.
from the current X, which should be 127. We're just
Mhm.
hard coding it instead of saying self dot, and then we're going to 190, which should go up. Then we're gonna go from 127 over to 190. Well, hold on.
Is that the same?
Yeah, it will be.
Yeah.
I got to change the 127. We're going to say this is going to, what, 240?
Yep.
Something like that. So that'll go over, keeping the Y.
Mhm.
Then we're going to go from 240 back down
It's 89.
to 89. Okay, so we're not using any selfs here. So her theory was when we use selfs, it was combining them.
That was interesting.
That was actually quite interesting.
So it goes. The middle one is going first. Then the bottom one is second. The top one is third.
Well, aren't you telling it to go?
I have a theory. I have a theory. Could be a very interesting theory. I'm going to delete all these. Last time we talked about stacks, right? A little bit.
A little bit.
My theory is that this guy is implemented as a stack. And the first movement that happens is the last movement we added. Not in the order we put him, but physically put him into this bucket. Physically created the move to. So what I want to do is I want to work backwards. I'm going to create a move to. The last move that should happen is the move that goes from a 240 down to an 89,
Mhm.
right? So we're going to move from position, well, we're going to move to position, X is 240, Y is 89. That's the last thing that we want to see happen. So that's the first thing I'll push onto the stack. Now, I'll push on top of that one on the stack the movement that goes from X is 127 to X is the over one, 240. So we're going to go to a position on X of 240 and a position on Y of 127. Okay. That's the second move. Then we're going to add another one, and this one's going to go from a X of 89. No,
120.
an X of 127. Hold on, we might need to.
Edit this.
Yeah, this is going to go an X of 127 and a Y of, I think we had, what, 190? This is going to go, this should be 190. So we're going to keep the Y alone. So the very first thing, if this works like a stack, we should go from X is 127 to Y is 190. Then the next thing should be after we pop that off the stack and do that, then we should have the new top of the stack, which is this guy. It says move from wherever you currently are to 240 and 190. Then the last thing will be move from wherever you currently are, which will happen to be 240, to 89. Okay.
Change the speed.
All right.
Should we just make them all separate?
I think we have to. It's possible that we can't predict. Well, it seems like we can predict, but maybe we can't necessarily count on the order that these guys happen.
It seems like the middle one's firing first.
What if we do tell them to run to completion? That's weird. Why is it combining the first two? So it's going up and over first. And up and over says these two are being combined into one, right? See, what if we do it relative to the actor? This says relative to myself, go up. Then relative to myself, go over. Relative to myself, go down.
It's worth a shot.
See, that's putting it on the XY coordinate where 0, 0 is his top left corner, not the scene's top left corner. It's just weird. Okay, well, so we, at the very least, can't reliably count on move 2 working in a certain order for us. So it's possibly considered an experiment with it and figure out the way that behind the scenes Game Salad happens to schedule the move 2s, but it's not going to get done what we needed to get done. So we need to do this a different way. So what do we suggest? Well, we can specify movement at a specific angle relative to the actor. Let's look at that. Actually, let's put our rule back in here. We're going to do a move at 90 degrees. Actually, relative to the actor is correct for that one. Actually, maybe this will be the... well, let's just do additive for right now. We'll do 100. So this should just make him go upwards at 100. But we need to make him stop at some point. Okay, so right now he should just start heading north and keep going north. Okay, so how would we make him stop when he... Go ahead.
If his position is equal to the top spot where we want to
The 190 or whatever.
an if statement and then go.
Okay, so inside of this actor, we might put a rule. Actually, let's just make the rule at the top level so we don't even have to hit a button. No, we'll hit the button. We like that better. So we're going to drop a rule inside of here. And the rule is going to say, if this actor's position on Y is less than 190, move up. As soon as it's at 190, what are we going to do? Let's just tell it to stop moving. Keep it relatively simple. So we'll move in no direction at a speed of 0.
We're not gonna move to the right. Oh,
Yeah, but we're not moving. Yeah, you're right. This technically is in a, so I misspoke when I said in no direction. We are moving to the right, but we're not moving. We're going at no speed. Okay, so we're kind of preparing for our next move to the right. All right. Now, we'll run this. So we should see him go up. Except I need to hit play instead of just manipulate a static scene, right? Okay. And then stop when it hits our 190. Okay. Now, we could adjust that movement to the right to say, now let's go to the right at a certain speed. So instead of going at a speed of 0, let's go to the right at a speed of 100. Okay, but we need him to stop at a certain point. So we're going to need to put a rule in there. Actually, we don't even need to make these nested rules. In fact, this will be cleaner anyways. This one's going to say move up. So as soon as we hit the touch event, in fact, I changed my mind again. We're not going to do the touch anymore. It'll just confuse things in this. So this rule says move up. So as long as our Y position is less than 190, go up in the air. Okay? As soon as it's not less than 190, stop moving up. So now when we start our scene,
we have it moving to the right.
do we have it moving to the right? Actually, it won't matter. It'll just kick over to the right. That's fine. Okay? Now, we need to have a rule that says, let's just drop a rule after this one. The actor position on X is less than 240, we'll have it keep moving to the right. Except we need to actually get that rule in there. Okay? Now we need to put a stopper up here though. So we do need to have him not move at all. So we'll physically do the stop. So this says move up until we hit 190, then stop. This guy says move over until we hit 240, then
Is it going to go diagonal though?
I don't think it will. We'll see. Let's find out. So move up until we hit 190, then stop moving. Move over until we hit 240, then stop moving. Ay. So it calls both of them at the same time. But, hold on, this might tell us something.
Isn't it because, like, even though the
It's less than 240, right? So we do need to have it nested. We need to have this loop. We need to have this rule inside of this rule. It needs to be the otherwise, like we were starting to do before. So as long as we're less than 190, do this. Otherwise, let's move to the right. As long as we're less than 240, go to the right. Otherwise, stop. So this should move us up and then over. All right. Then inside of this otherwise, in place of this guy, we need to have the landing. So we'll have another rule inside here that says this guy's position on X is greater than 127. I'm sorry, his Y is greater than 127, not his X. His X is where we want him right now. While his Y is greater than 127, that means he's too high. So we want him to drop.
Didn't we want him to drop to 89?
Yeah, but
Am I getting my numbers mixed up?
then you'd want it greater than 89. I mean, less than, yeah.
Where did he go to initially?
You started at 89.
He went up to
I
190.
need to go up here.
It went to 190.
Yes, we went from 127 to 190. So now as long as, if we're in this otherwise, we've just been moving to the right. As long until we hit a 240 on X. Then we get to the otherwise. The otherwise says if our Y is greater than 127, which was our original starting point, right? Isn't that correct? Let's check that real quick.
Yeah.
Our original Y, is 89.
Yeah.
Okay, I get it. I get what you're saying. Okay, so as long as we're greater than 89, then we want to move downwards.
What about if there's other discs in the way?
Oh, right. I mean, that's what we need to put in our logic for dealing with the individual towers. Well, let's just get our movement down. But yeah, absolutely. Yeah. So we'll move down at a speed of 100, and then our otherwise will be stop moving. So just change the speed to 0. So the hope is that this guy does all of our the two rules are fighting each other.
Who's gonna win?
Now, we specifically said last time we were not going to use a timer for this because it was a bad idea, even though timers will clearly work. So we can throw some ands in here. So if Y is less than 190, the heck? Just like suck at clicking, I guess. And our actors X is less than 240, then move up until we don't move up. Then, as long as our X is less than 240, move over. Then, as long as our Y, I think this will work. By we stop them competing with each other by putting this and less than 240 up here. Because down here, we will be at 240. So it'll be this rule that fires instead of the one up above.
Hey.
Okay. Now, I think we've seen that before, right? Have we done ands in here?
No.
Okay, so this is saying we want, I did this on purpose, okay? So this is saying that both of these conditions must be true in order for this rule to fire true. So let me just name these real quick. This guy's move to the right. Right. Move to the right. And this guy is move down. Okay? So this first one, we only move up if our current y is less than 190. So we're down here. We only move up if our current y is less than 190 and our x is less than 240, this guy over here. So the only time that's the case is before we've done this move over here. Because once we move over here, our x is now 240. So that first rule won't fire anymore. And then we're allowed to drop. Okay? So that allows us to move. Now, something I want to mess with here.
You want to save it before you mess with it?
Okay. Oh, can we not create? Do we just need to sign in, or do we need to have a... We can create our own custom behaviors. But we might have to have the pro version to do that. The beta used to let us do it, but now they actually sell this. No. Okay. Well, I was going to wrap this inside of our own behavior that says, you know, move over 1 tower. You know, disk move 1 tower, something like that. And then we can have another behavior that says move 2 towers to the right or something like that. But yeah, that's not going to fly for us. So, in any case, if you spend the $500 on the software, you can do that. You can essentially write your own functions, your own behaviors, give them a name. They'll show up in this list under your custom behaviors. Really, that's just dumb that they won't let us do that. Okay, so in any case, we're not going to be able to do that. So this lets us move over 1, let's just say, but it does not take into account the number of disks we're landing on. Okay, so we need to be able to control how many disks are on our destination tower, and as well as maybe which disk we are in the source tower. So just for the sake of our argument here, let's add an attribute. Make it an integer. We'll say source tower. We'll add another one. Type integer called dest tower. Okay. Now what we're going to say is when we're landing on the bottom, well, let me think about this. I'm not sure it necessarily matters. We just need to be consistent. If we have, let me go back to our previous scene just to depict what I want to depict here. If these are our towers.
Towers are all at the same time.
No, right. But we want to ask, like, for instance, if our source tower, we click here, the top disk that's coming off here is this guy. As opposed to if this guy only had 1 disk in it, he'd be coming off of here. So this guy would need to take off higher relative to himself than this guy would. Does that make sense? Because we need to just get him here. Now, we don't necessarily have that problem for the taking off part, because of they're all going to take off and go to the current place. So as long as we know where the source is, we'll know which disk to make rise. Because what we don't want to have is we don't want to have a tower that looks like this and have the bottom one just start taking off through the other ones. Unless we're going to put on collisions and it just becomes like a Royal Rumble type thing. So, any case, we are going to need to keep track of what the top of each tower is in any case. But more importantly, didn't we determine last time that I'm incapable of dragging these? Okay, good. Just as long as we covered that. So let's say this guy's coming from this tower over here. And he's going towards this tower over here. I like to do it in super slow-mo. That way it's like there's a greater sense of anticipation, right? Okay, so now if we were to choose this guy as our source and this guy's our destination, this guy will take off. We're going to move him to a position here. So we don't need to worry about which disk this was, other than making sure we're moving the right disk, and visually we're not going to move a disk that's below another disk, right? But we don't need to deal with his height. He's going to take off up to a point. He's going to move to this point. All right, now once we hit that point, then what are we going to do? We want to move over to this point. This point is static. The point above each tower is a static point. It's not going to move. But now, landing is where we need to be careful. We don't want this guy to land all the way to the bottom of the tower, invading the personal space of the large orange disk. We'd rather have him nicely land on top of the other two disks. So we need to keep track of, does he land here, here, or here, based on the state of our destination tower. Go ahead.
Just use collision instead.
Oh, we absolutely could use collision. That's a very good point.
That way they wouldn't.
It wouldn't, if it hits it, then it just stops.
A very good point. Couldn't we use collision on the other part too?
Yeah.
We could just have him go up until he hits something. Until he hits this button.
Yeah.
And then when he hits the button, what happens?
He goes right.
Well, probably turn off his upward motion and then make him go to the right. Interesting thing for us to look at here real quick. Let's see. Let's go into this screen. Let's give myself a different actor here. And okay. We're going to have this guy be able to collide with this guy. Okay, so this is our actor 2. Our actor 2 is going to have the collide behavior, and he collides with an actor of type actor 3. Now, we're going to say actor 2 immediately is going to start moving upwards at a speed of 100. Okay?
And the other guy moved.
Probably.
Oh,
Well, we don't have gravity turned on.
okay. Yeah, that's what.
Oh, right. I get what you're saying now. Get out of my way. All right. That's under physics, right? Movable. He's no longer movable. Now we can just bump into him. Now, when we bump into him, we want to have him move over. Now, what we see right here is notice that he's still trying to move up. He's just being held in place because we can see him there shaking, right? All right. So rather than making him collidable, let's go ahead and create a rule that says this particular actor overlaps or collides. Actor receives event, overlaps or collides with actor of type actor 3. And if that happens, then let's have him move to the right.
Will he still be moving up though?
Well, that's what we're going to see.
You want to make it stack then? If you make it stack, wouldn't it? I know.
Stacked, well, it shouldn't actually make a difference for this test. We want to know if when he collides, when we say to start moving someplace else, does it stop the upward movement? Are you always moving in one direction or another unless it's additive? We'll do the difference between stacked and additive here. So as soon as he hits, we expect that rule to fire. And that rule says move to the right. But will he also then move up as soon as he clears this thing? And will he stop moving to the right? Does that make sense? We want to know if those movements are an on or off switch. Or once we start the movement, is it just on? So I'll hit.
Ooh.
Actually, he only collided for a second there.
Moved right through.
Okay, but at the very least, we should have noticed that he stopped moving to the right. So the rule did turn it off. Watch this again. See him stop moving to the right? So as soon as he stopped colliding, he stopped moving to the right. Now, if we come into actor 2, additive or stacked will not make a difference here.
Can we make an if-then statement? If he's not colliding, move up. I don't know. Never mind.
Couldn't we just make a ceiling actor that would cover the entire screen?
No, we definitely could. But we're still going to be bumping up against it. So we still need to get the behavior of let's stop moving when he collides. So
Could you do like the stop moving, but then add a move two to go to the right? Or are we trying to completely avoid move twos?
no, we can do move 2s. So we're going to say move up until you hit. Once you hit, move to the right. Actually, once you hit stop moving, then we'll put a move 2 in here eventually, but let's just say move to the right at 100. Let's say if we need to stop him and then start him. Does that make sense? As opposed to just changing direction.
Is that move to the right gonna happen?
This happens when we overlap or collide with the orange guy. So we should rise, hit, stop, then move to the right. Okay. So this guy needs to be inside of something. So why don't we put him in the otherwise here? As long as we didn't hit, do this. But this rule is going to fire over and over again based on collisions. It's not based on an attribute, which only fires once whenever the attribute changes.
What if the collision said a Boolean?
We definitely could do that. When to move up. I'm allowed to move up as long as this Boolean is true. So we can, inside this actor, actually we can do it inside of our first actor. We'll just simplify this whole thing. We'll add 3 Booleans. Move 1. Move 2. Move 3. We're going to go up as long as move 1 is true. So we'll have the other 2 set it false. Actually, I think that's true and false, false. So as long as move 1 is true, allow him to move up. So we're going to create a rule that says the attribute, this guy's move 1 is true, we'll have him move upwards. at a speed of 100. That says move up. Now we're going to have another rule out here that's going to say if our actor, or our actor's attribute on y is greater than or equal to 190, then we will change attribute move 1 to false. We have to have an otherwise up here. If you're not moving up, what are you doing? You're not moving. So this says move up as long as move 1 is true. We have a secondary rule here that controls the value of move 1. Secondary rule says as long as your y is great, as soon as your y becomes greater than or equal to 190, change move 1 to false, which should then make this guy stop. That make sense? So he should rise until he hits 190. We don't even need this guy anymore. Actually, we don't even need either of these guys anymore because we're not writing the code for them. This guy should rise until he hits 190 and then stop. Because he's not rising because he hasn't hit 190. He's rising because move 1 says he's allowed to. Move 1 says, I'm true, 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 true. Now I'm false. Stop moving. Okay? Now, we want to have the rule that moves to the right. That's our move 2. So as soon as we turn move 1 to false, we want to also change the attribute move 2 to true to let him start moving in the right direction. That make sense? We turn move 1 off so he can no longer go up. But he's going to constantly try to move to the right. We haven't written the rule yet, but he's going to constantly try to move to the right as long as move 2 is true. So we'll throw a rule in here. I don't know where that rule ended up.
It's around again.
It's around the whole thing. Let's just undo that then. Let's drag a rule out. So move right. We can do this as long as the attribute, our actor's move 2, is true. And what will we do? We're going to move to the right at a speed of 100. Otherwise, we will stop moving. Here, just for the sake of argument, we'll stop moving to the right. Okay? So this says move right, only move right as long as move 2 is true. So this says, this rule is to adjust move 1. Now we need another rule to adjust move 2. Adjust move 2 says if actor 1's position on, let's do Y first, is greater than or equal to 190, and his position on X is less than or equal to 89. Actually, we'll do greater than or equal to 89. We'll have him move downwards as a result of this. If it's greater than or equal to 89, then what are we going to do? We're going to change an attribute What attribute? Move 2 to true. Actually, move 2 became true down here, so we will make him false here, which means that we do want it to say less than or equal to 89. That's our adjust move 2. So he'll go up. Let's go back here. He'll go up as long as move 1 is true. As soon as he hits a position where it's y is 190, move 1 becomes false, move 2 becomes true. Move 2 allows him to move to the right. So he'll keep moving to the right as long as move 2 is true. So he moves to the right until he hits a x of...
But wouldn't the x never be less than or equal to 89 then?
I believe you are correct. What do I have it written as? We need to do change, adjust move 2. Just move 2 says your y is that position. Oh, we want to say less than or equal to 2. We want to say greater than or equal to 240. As soon as it hits 240, set it to false. That makes it not go to the right anymore. Okay? So this guy should take off until he isn't allowed to go on move 1 anymore. Then move 2 becomes true. Take off until he's not allowed to go anymore. Then the last one will be setting move 3 to true. So when we set move 2 to false, we'll also set move 3 to true. And what do we do on that guy? Well, we have a rule called move down. And this guy says as long as an attribute, move 3, is true, then we're allowed to move downwards. Otherwise, we stop moving downwards. So as it's written right now, he should take off, go over, and then go down forever because we don't have our change. Okay, so we'll come back on Monday. We'll add in the change. We'll do the math for our landing on a disc of different heights. And then for your homework assignment for Wednesday, if you want to start working on it earlier, you're going to implement the Towers of Hanoi. Okay? I will see everybody on Monday.